Hello and Assalamualaikum. My name is Nur Ain binti Abu Bakar. So for today, I would like to present about the data mining task, which is regression by using Microsoft Excel. First, in order to conduct the linear regression, we need to remove the outliers from the dataset because outliers can skew the results. So as we can see here, first we are going to calculate the first and third quartile just using the function quartile function, and then we're going to select the array as we have 504 514, yeah, and then just select one for first quartile, we get 0. Next, for the third quartile, we are going to use the same formula. Choose your array, set is 514, but this time we are going to use 3 as for third quartile. Next, to evaluate the interquartile, just subtract between third quartile and first quartile, so we will get 6.57. Okay, we will proceed with to calculate the lower and upper bound in order to use them to identify the outliers. So just equal, take our first quartile and then minus with 1.5 multiplied by our interquartile, we get negative 9.88. Next, for upper bound, just get our third quartile plus by 1.5 multiplied by our interquartile. Okay, we get 16.425. Okay, next, in order to identify the outliers, we are going to use the OR function. So OR, and then we'll select this array. Okay, this array smaller than our lower bound, comma, select the array again, greater than upper bound. Okay, just click enter. So we get the false. When we get the true, it indicates as outliers. So just click comment for, okay, and then just copy that value and for our data set. As we can see here, there's a false and true over here. So the true value, as I said earlier, it indicates an outlier, so we can remove the data which has the true value, and then we can proceed with the linear regression. Basically, regression analysis is used to estimate the relationship between two or more variables. So in this case, we're going to use the simple linear regression, which is we can find the relationship between dependent variable and one independent variable. So for this case, our dependent variable is area, because this is a factor which we are trying to understand and predict, while the wind is the independent variable, which is the factor that might influence the dependent variable, which is area. Okay, so first, in order to conduct the linear regression, we are going to select data over here in the data section, and then select data analysis, regression. Okay, so for the input y is our dependent variable, which is area. We are going to select 542. Okay, next for our X, which is wind, 542 also. And then we are going to select labels, output range over here. I want to put it over here. Click enter. And then for the residuals, we are going to tick this because we want to see the difference between the predicted and the actual values, and then click OK. Okay, so this is our summary output. So over here, this part tells us how well the calculated linear regression equation from our source data. Next is ANOVA section, but for a simple linear regression, we rarely use the ANOVA section. Okay, next, so this is the most useful component in this section, which is coefficient. It enables us to build a linear regression equation ourselves, which is y equal to bx plus a. The residual output, as you can see over here, the predicted burn area is 2.59 when the wind is 6.7. But as you can see, there is actually a slightly different, because over here the actual burn area is which is 0. So there is a difference between predicted and actual value. So why it is different? Because independent variables are never perfect predictors for the dependent, and residuals over here can help us understand how far the actual value are different from the predicted area. So when we subtract the 2.59, which is predicted value, with the residuals 2.5 negative 2.59 also, we actually can get the actual burn area over here. So that is the function of the residuals for the residual output. Next, we are going to make a linear regression graph using access in order to quickly visualize the relationship between these two variables. So just select both of it and then click insert. You select our scatter plot and click OK. So we can see over here, this is our relationship between the wind and burn area. So next we are going to build the regression equation. So just right click and then click the add track line. So we choose the linear option, automatic, and then display equation on chart. And then we can choose the color, solid line. So we using a different color, which is red. And then as you can see, we can see the regression line over here. So this is our regression formula, linear regression formula from the coefficient output. Okay, then we are going to make a few more improvement for our graph, for our scatter plot. So just click axis. Maybe we can add the title, the axis title, which is area, and then area. Okay, and then click it again. Our vertical, which is wind, and then our graph title, which is linear regression. Linear regression. Okay, so this is a linear regression. so it will look like more presentable and readable. So next, we also can actually put our predicted area into the graph, so we can compare between the actual and predicted. Okay, so we will, okay, decimal point with small, we make it small decimal point. Okay, and then we Ctrl C to copy all of it, and then click on the graph on the scapula, and then Ctrl V, which is pasted. So as we can see over here, we can look the predicted in the orange color. Okay. Next, we will repeat the same step from the step 1 until we can get the graph for the variable temperature, rain, and humidity. So that's all for the linear regression. As for the result, we can conclude that burn area increases by approximately 0.23 hectare with each additional degree of temperature, percentage of humidity, and millimeter of rain, while burn area increase only by 0.19 hectare for each additional speed of wind. So we can see that speed of wind has the least effect on burn area compared to other factors. So that's all from my part. Thank you for watching and listening.